Hello, Algebra 2 people. Here we go into preparing for your Chapter 2 exam. And so this is going to cover the first practice exam. So the first problem says a parabola has an axis of symmetry of x equals 2, and it gives us a particular point and wants us to find another point based on the symmetry of the graph. So x equals 2 would be right here. And if I mapped out 6, 5, so x would be 6. The height here would be 5. So that puts me 4 places away from my axis of symmetry. So if I go back equidistant 4 places, that would put me at -2, and I'd want to be at the same height, so that will be at the coordinate -2, 5. Now, let the graph of G be a vertical shrink by a factor of 1/2, followed by a translation 2 units left, and then followed by 3 units up of this graph. All right, so the blue, since it's vertical, is go on the outside. So that would be 1/2 f of x, so that would become 1/2 x squared. Then followed by a translation 2 units left. Left is in the negative direction, and that's horizontal. So that's going to mean we will be doing, I should have started this earlier. I guess I'm going to work this way. So we still have the 1/2. Now on the inside, because we're going left, we put a positive there. And the last change is 3 units up, which again is vertical, so it goes outside the parenthesis. And then to write our new equation, it will be 1/2 x plus 2 squared, because that's the actual equation, parent graph, plus 3. All right, so just do them step by step. This is showing sort of the functional notation, but you actually want to write it as a new equation. This next one asks us to find the axis of symmetry, the vertex, and the y-intercept of something in vertex form. So remember, this is going to represent your h, and this is your k. So that means my axis of symmetry is x equals 1, and 1, 3 is the vertex. My y-intercept, you got to work for that one. We're going to plug in x is 0. So we have y equals -4 times -1 squared, which is 1, plus 3. So -4 plus 3 is -1. That will be our y-intercept. Okay, now determine whether linear or quadratic models the data and justify your response. So notice my change in the x's is +1, +1, +1. Down here I notice 7 minus 5 is 2, 11 minus 7 is 4. This is going to be 6, this is going to be 8. We have a pattern, but it's not constant. So that right tells me it's not linear, because you want everything to be the same. But then we go 4 minus 2, 6 minus 4, 8 minus 6. That is called a second constant difference, and that is what tells us we have a quadratic equation. Sorry. Quadratic, because I wonder if I can pause this for a sec. Okay, because of the constant second difference. All right, now let's find ourselves some equations. Write the equation of the parabola. So this first one, it gives us the x-intercept. So that's giving us √1, √2, and passes through a particular point. And so what we do with that is I recommend you write down the generic equation first, x minus √1, x minus √2. we're going to plug everything in and solve for a. So I'm not sure what I just hit, but I want it to go away. Let's see, sorry about that. So y is 2.4 equals a. X is always going to be 4 minus the first root, and then 4 minus a negative 2, the second root. So I have 2.4 equals a times 1 times 6. So 2.4 divided by 6 is actually going to give us a equals 0.4. And then we plug it all back together. So we have y equals 0.4, x minus 3, and x plus 2. So make sure you have an x and a y in your final answer, but all other variables should be filled in. This next one, it's giving us the vertex, which is our hk, and a particular point. So we are going to use vertex form. So vertex form is y equals a, x minus h squared plus k. We plug in all this information. The y value is a negative 3. This is a. X is going to be a negative 5 minus a negative 4 squared. And then k is a negative 6. So let's kind of clean this up a little. We have ourselves negative 3. Here's a. 4 minus 5 is a negative 1. Squared is still going to be 1 minus 6. So the first thing in solving for a is we add 6 to both sides. So that's going to give me 3 equals a, and we're done. So putting it all together, y equals 3, x minus a negative 4, because that's my h, minus 6, because that's my k. All right, now let's see what we have. Find the max minimum value of the function, find the domain and range, identify the intervals where the function is increasing and decreasing. So, in terms of sketching a graph, all you really need to know is because a is negative, this graph is going to have a frown, okay? So what I recommend you do with these is just go ahead and find your vertex, because everything's going to be based on the vertex. So in standard form, which is what this is, the vertex starts off with opposite of b over 2a. So negative 12 over 2 times a negative 1, that is going to give me a positive 6. Then we plug that in to find out what the corresponding y value is. So negative 6 squared, remember only the 6 is getting squared, plus 12 times 6 minus 30. So we have ourselves negative 36 plus 72 minus 30 is going to give me also a y value of 6. That was a little bit unfortunate, but that's the way that was. So find the max or minimum value. Since this graph is upside down, this is going to represent a max at the y value of your vertex, because that tells you how high. You are 6 yards or miles, however high. Domain is always all reals for the domain of a quadratic. The range, since my maximum is here at 6, it'll be y less than or equal to whatever that y value was. In this case, that was 6. Now, for increasing and decreasing, this is really about the axis of symmetry. So it's going to be based on the x value of your vertex. So I always write down right away x and 6, x and 6. And it's a matter of, well, which is happening where. So we're reading from left to right. So in the beginning, notice I'm going up. So before I hit the vertex, I'm increasing. So that means this is x is less than. After I hit the vertex, I'm decreasing. So for all x is greater than 6. All right? All right, now we're into the graphing portion of the exam. So we're starting off with standard form. Standard form, remember to find the vertex is going to be the opposite of b over 2a. So negative 6 over 2 times a negative 3. That's a nice friendly 1. So then we plug that 1 in to find out what y equals. So negative 3 times 1 plus 6 times 1 plus 4. That gives me 3 plus 4, which is 7. So my vertex is going to be 1, 7. The y-intercept, remember that's always going to be when x equals 0. So it will always be that c value. So y equals 4. And we're going to use that in the symmetry to draw the graph so that we get our 3 points. Domain is always all real. And if you're not sure about the range, let's graph it first. Okay, so I have here, always label your axes. There's 1, 1, 2, 3, 4, 5, 6. Here's 7. So 1, 7 is right here. So there's my xy axis. We know this graph is going to be a frown. Let's find our y-intercept is at 4, 6, 5, 4. And now it doesn't ask you to draw your axis of symmetry, but just so you can see how that symmetry helps in graphing, I know I'll also cross at this point on the other side, and now we are ready to just draw our parabola. So now we can see the range is going to be all y less than or equal to the y coordinate of your vertex, which is 7. Okay? This next one, it comes to us in vertex form, so that makes that easy. Your vertex is going to be, you always take the opposite of what's in the parentheses. That's your horizontal translation. But then the vertical is exactly what you would expect. So we're going to go out here to 2. 1, 2, here's at 3. So the point 2, 3, that's going to be my vertex. The y-intercept, we're going to have to do a little work here. So we're going to let x equal 0. So this is 1/8, 0 minus 2, so negative 2 squared plus 3. So this here is going to be 4, so we're going to end up with 3.5. So my y-intercept will be at 3.5. It's a little bit tight. And then using the symmetry, 2 away, here's another 3.5. So that would give me my graph. And then we have the all real for the domain. And you can see from the graph that it'll be all y now greater than or equal to 3. Okay, now we come down here to intercept method. So I know that you're setting each one of these equal to 0. That's how you find the roots. So x will be 1 and negative 5. And that's what we put on our graph. So here's 1, 1, 2, 3, 4, 5. Here's negative 5. And you can either do the official, find the average of those two. So that's negative 4 over 2, which is a negative 2. That will be my axis of symmetry. So that means that's going to be the x-coordinate of my vertex. To find the y-coordinate, I have to plug that in. So y is going to equal 1/2, negative 2 minus 1, and negative 2 plus 5. So this is going to give us a negative 4.5, negative 9/2, or negative 4.5. Negative 4.5. Didn't give you the friendliest numbers on this, did I? Okay, so negative, let's see, we're down here, 1, 2, 3, here's 4, so 4.5 would be right here, and our 3 points come from the vertex and your intercepts. And then just, oh, that was not very symmetrical, but hopefully you guys are okay with that. The y-intercept, if I wanted to know the y-intercept, once again, you're going to let y be 0. So if I let y be 0 here, x equals 0, all right, that's going to be 1/2, where can I show the work here? 1/2 times a negative 1 times 5, so that's going to be a negative 5/2, or negative 2.5. which, see, that was good. I made that not very good graph over here because I didn't really hit in the right spot. We want to hit at 2.5. 1, 2, negative 2.5 is right about here. Now it even looks better. And I would use the symmetry, but I already had my 3 points. So y equals negative 2.5. Domain is all real. Range y is greater than or equal to negative 4.5. Always based on your y coordinate of your vertex. Okay, last one. This one is also in vertex form. Notice that there is no plus k here, so that means my vertex is negative 2, 0. My y-intercept would be 116 times 2 squared, so that's 4 over 16, or 1/4. So let's come back here. So we're here at negative 2, 0, right on the x-axis. 1/4 is going to be my y-intercept, so go back to 1/4. So it's going to be a very wide graph because 1/16 is a very, large, I guess, vertical shrink. It really shrank down, so it makes it very wide. Y-intercept, we found that. That was y equals 1/4. This is always all real, and now the range, y is greater than or equal to 0. Okay, so I hope that was helpful. On to the next page. Okay, here we have Nick and Jed competing in an archery contest. Nick's shot is modeled by the equation, so this is going to be Nick, n of t for Nick. And t is time in seconds after the shot is taken. N of t is the distance in meters the arrow travels. Jed's shot is going to be modeled by the graph over here. So notice Jed's shot starts at 0, 0. It lands, so everything here is going by 2 at 6 meters, so that's 6 meters. And the height, so if this is 50, 52, oh, that's not even by 2s, that's 10, 20, 30, so this is going by 10, so 60, 70, looks like about maybe 72. All right, so we need to figure everything out. So we have that Jed, because his is easy to read from the graph. Let's find his stuff. His height is going to be 72 meters, and his distance is going to be the distance in meters the arrow travels. Who shot the arrow higher? Okay, so that's all we're answering right now. So his height is 72 meters. What we need to do now is look at Nick, and Nick is based on his equation. So I'm going to do his work down here. So we have 6t and then 10 minus 2t. So we set each one of these equal to 0. So his also starts at 0. I'm going to kind of superimpose it here. And when we set this second equation equal to 0, we get t equals 5. So he's going to end right here. But we want to know, what is his height? Well, we know that if his intercepts are at 0 and 5, the vertex will happen at 2.5. So we need to plug in 6 times 2.5 times 10 minus 2 times 2.5 to find his, and of course you're using a calculator on these. So when we calculate that out, you're going to get 75 meters. So let's see, this was 72. So 75 is going to be a little bit above that. So here is Nick. So Nick's shot, his height is 75 meters. So who shot the arrow higher? Nick's shot went 3 meters higher. And as long as you're showing your work, you can consider that as a justification. All right, let's look at this next. Who shot the arrow further? Well, we can see that Jed's shot went 1 meter mounted in the graph to the right. Jed shot went 1 second longer because X actually is in time in seconds. So if he went 1 second longer, his shot is going to travel further. Okay. All right, let's look at number 13. Given the following data, justify that a quadratic equation models it. All right, so with this, all you're really showing me, we're kind of giving it away that it is quadratic. What you're going to do is just show the constant rate of change on top. Notice it's +1, +1, +1. Down here, we're going to have -9. Then we're going to have a -5, then a -1, then 3, then 7, and then 9? No, 11, sorry. Okay, then we do the next. It's like, okay, well, that's not linear. So -5 plus 9, because minus a -9, is going to give me 4. -1 plus 5 is 4. 3 plus 1, that's going to be 4. These are all going to be 4. So C work is showing me that this is your second constant difference. Okay, so now they want us to come up with the equation. And so I strongly recommend, if you can use any points you want, use everything right around the 0. Okay, that'll make it a lot easier. So we're going to be plugging it into, let's kind of put this equation up on top. Y equals ax squared plus bx plus c. So the first equation, actually, I'm just going to go ahead and do it. So the y value is 4, which equals -1 squared, so that'll be a, plus b times a -1, so that'll be minus b, plus, I'm going to give away something. We were given a gift here. We're going to find out that c will always be 3, so I'm just going to go ahead and fill that out. But you'll see it in this next one. So y is 3, x is 0, plus b, x again is 0, plus c, so we know that c is going to be 3. So anytime you're given the x is 0, the y coordinate will be your y-intercept, which will be that value. It's kind of friendly. Then we have 6 equals a times 1 squared plus b times 1 plus c, which we know is 3. And so I'm ready to, I really just have a system of 2 by 2. This isn't too bad, but I'm going to simplify it. So this can become, subtract 3 from both sides, 1 equals a minus b, subtract 3 equals a plus b. We can just add these together, so 4 equals 2a, because the b's will cancel. So now we know that a is 2, and if a is 2, 2 minus what is 1? That's going to be b is 1. And then we need to put it all back together. So that gives us y equals 2x squared plus x plus 3. And that would be your final equation. All right, we're almost there. Okay, so now a couple multiple choice. Select all that apply. So all these refer to axis of symmetry, vertex. So we're in standard form. So x equals opposite of b over 2a. So -4 over 2 times 2 is going to be a -1. So y is going to equal 2 times a -1, which is squared, which is 1, plus 4 times a -1, so -4. Be careful of those negatives, plus 1. So -2 plus 1 equals another -1. So my vertex is -1, -1, and the axis of symmetry is -1, and that's all we can do. All right, now we're in intercept form. So I know my intercepts are -1 and 5. So -1 and 5, -1 and 5. So that's going to be this one. So -1, 0, 5, 0. That's where we cross the x-axis. Y-intercept, we're going to have to plug in x equals 0 to figure that out. So this will be 0 plus 1, 0 minus 5. So that gives me 3/5 times a -5. Those will cancel, and I'll get a -3. So the y-intercept is going to be 0, -3, and I believe that's it.